Good day, ladies and gentlemen. Take out your note sheet for 8, Tack 1, adding and subtracting polynomials.
So this next unit we're going to look at, we're going to be talking a lot about polynomials, and polynomials can have more specific names to them, and really comes down to the prefix that you would see with these. So a monomial means one, binomial would be 2 parts, and a trinomial is 3 parts. Anything beyond that's just considered a polynomial. So you can include that with each of these maybe underneath, but we're going to look at an example for you to put on the line for on your note sheet. So what do we mean by monomial being 1 part? Well, these are both examples of monomials. You can pick one of these and put them on your note sheet. But basically, monomial means 1 part. And this, I know there's all these different bases, but there's nothing separating any of these. This is just a big group of multiplication, so that's considered 1 part or a monomial. Same thing as something like 5x, that's still considered a monomial. If we take a look at a binomial, and I've highlighted in a different color the separation, this is now 2 parts because you've got this plus sign in between your 2x and 1, so now you're separating these into 2 different terms. Or your second example, x squared minus 2x, the minus sign is separating, so now that's technically 2 different terms within this binomial. And then a look at a trinomial here, so again you can kind of see tri means 3 parts, so we've got 3 different parts with those separations in between of the plus and minus. Another example to the right, maybe just xy plus y squared minus 2z. So really, if we're taking a look at these, what we can kind of conclude is that the addition or subtraction symbol is used in order to separate the parts of a polynomial. So anytime you see those, then you can count it as 1 part, 2 parts, or 3 parts, or even more than that would be a polynomial. So a definition for a polynomial, and you can write down from here whatever you want, you can even summarize in your own way, but a polynomial is basically just a generic name for any kind of term with 1 or more parts. And it can also describe monomials, binomials, trinomials, or an expression with more than 3 parts. So it's the generic name for saying you've got these letters or variables, sometimes with exponents and sometimes with constants in front of them, and you might have just 1 part, you might have 2, you might have 3, you might have 4, and that again is just generally classifying everything as a polynomial. So we're going to talk about degrees, and when we talk about a degree of a monomial, and this is monomials, the degree of a monomial would be the sum of the exponents of the variables. So you basically look at all the exponents and you would just add up any exponents that you see, and that's considered the degree. So we've got a couple examples here where you've got something like 5x squared. So the only variable I have is x, and the only exponent value that I see here is that it's an x squared. So if I was going to name the degree of this monomial, it would be 2. The second example here, you've got these exponents here. You've got a 4, a 3, and then don't forget that that's technically a c to the first power. So if you had to state the degree of this monomial, you would do 4 plus 3 plus 1, and that degree here would end up being a degree of 8. And then your third example, you've got negative 3, no variables at all. So a degree is talking about the exponent value of the variable. So if there's no variables, this would be a degree of 0. So the reason that we talk about degrees, and then we talked about the monomial, binomial, and trinomial, is it's just a way you can name polynomials and be more specific. So you typically would name polynomials based off of the number of terms they have, or the number of parts like we looked at, and then what the degree of the polynomial is. Now, we looked at just now how to find the degree of a monomial. The degree of a polynomial is a little different. The degree of a polynomial is just asking you to find the largest degree from all of the terms in the polynomial. So you actually just look at them and you find the one that's the biggest, and that's your degree of the polynomial. So we'll just look at how you can be more specific at naming these different polynomials that you see here. And to name them again, you're going to look at how many terms they have. So this first one, terms, remember, are separated by plus or minus. So I see that there's 3 terms, so that's a trinomial. Next thing is degree. And so degree of a polynomial is not the same as a monomial because these are separated with plus and minus signs. So to name a polynomial degree, you have to look at the highest exponent that you see. And I have an exponent here, and technically an exponent here is a 1, so the highest that I see is the 2. So if I had to name this, then this would actually be called a second degree trinomial. Second degree because of that 2, and then trinomial because there's 3 parts. The next example, how many terms do you see here? It should be 2 terms, so that's a binomial. The degree is the highest exponent you see, which is that 3 with the 3y cubed. So then if you had to name this, it's a third degree binomial. And this would just be getting you guys to understand how to basically name and classify these different polynomials. So go ahead and see if you can pick the correct answer for this one, and then press play when you're ready to check what you get. Okay, so this should have been a 5th degree polynomial. You would look at how many parts it has, and there's 1, 2, 3, 4 different parts, and anything beyond 3 parts, which is a trinomial, is just called a polynomial. And then the highest degree here is the 5th, so it's a 5th degree polynomial. Okay, this is not on your note sheets, but this is just kind of getting you prepped and ready for how you're going to expect to see things. But polynomials, whenever you're actually doing any kind of math with them, you are going to want to put them in descending order. And so just a review of what descending means. D means going down. So descending order for a polynomial would be going from largest to smallest exponent. You don't worry about the number in front. You put it by degree, or the exponent value is highest to lowest. So this is just taking a look at how you would put these in descending order. If these were your answers, you're never going to see something that looks like number 1 as an answer choice. They're going to have it in descending order by degree. So the highest degree in this first example is the x to the 4th, so that should come first, followed by that x squared, so you're just kind of rearranging, followed by the 8x, and then there's no degree with the 4, so just minus 4 at the end. The second one says put in descending order in terms of x, and that's because you have x's and y's. So we're actually going to focus on the x exponents and put it in descending order by the x's. Don't worry about the y's. So the highest x that I see is this x to the 3rd, then x to the 2nd, and then here's an x to the 1st, no x, so that one would go last. So if we had to rearrange this in descending order, it should look like this right here. So that's just kind of getting you in the habit into what's considered your standard form of your answers for polynomials. So what we're really going to be doing with these polynomials is looking at how you're going to add and subtract them. And this is actually easier than what we've done before. So if you're starting to think this might be hard, it's actually super, super easy. So here's your rules for adding and subtracting polynomials. First of all, you can only add and subtract like terms. And to be a like term, they have to have the same variable and the same degree. So the same variable and then the same degree as well. So if it's x squared, you can only put it with another x squared. And we've kind of already done some of that earlier this year anyway. Second thing, in order to actually combine these, you're going to keep the sign in front of the term and then add or subtract that term with any other like terms. So basically, adding and subtracting polynomials is like combining like terms. It's really combining like terms. And just a kind of reminder that you are not changing the degree of the exponents, they will stay the same. If you have x squared plus x squared, you're not changing that it's a squared, that would just become 2x squared. So our laws of exponents, I know, is when we change those numbers around, but when you're adding and subtracting these, you don't have to change the exponents, you just add the number or subtract the numbers in front of the variable. So for adding and subtracting, again, all you really need to think about is look for like terms, add or subtract the like terms. So in this example right here, and this is where people like highlighting, I have got this a squared, but I don't have any other a squared, so I can't do anything with that. So if I look at what else I have a 3ab, and then I've got this 4ab over here. So I know those are like terms, they have the same variable and same exponent value, so I'm really just going to do 3 plus 4. And then lastly, I have this minus b squared, which would be minus 1b squared, plus 6b squared. Since they're both b squared terms, I'm allowed to combine those together, and I would end up getting 5b squared. So final answer here in degree order from a would be 3a squared plus 7ab plus 5b squared. Second example, again, I'm really just looking to combine like terms. So I've got 2 different a squared terms I'll put together and then 2 b terms I'll put together. And we're not changing the exponents, we're just adding the numbers in front. So if you had 3a squareds plus 4a squareds, you're going to end up with 7a squared. If you have negative 2b plus 6b, you're going to end up with plus 4b as your final answer. And that's it. You can't do anything else, so you're done. Here's a third and fourth example, so I'm going to go ahead and actually highlight or underline the like terms that I see, and then I'm really just combining those using the sign and number in front. So in example 3, some of the like terms that I see is 2a squared plus 3a squared, and I know I can put them together because they're both a squared. That's 5a squared. Underlined in blue, I have a negative 1ab plus 5ab, so negative 1 plus 5 is positive 4ab. And then I tried to put different symbols for the other two. So I've got plus b squared and then minus 7ab squared. Neither of these have anything to combine them with, so the order doesn't really matter, but if I'm going by a down by degree, then I would probably put the 7ab squared and then b squared at the very end. And then in example 4, so I have 6x squared, and then I have a plus x squared over on the right, so that's really a 7x squared when I combine. Circled in red, I've got 3x minus 4x, which is negative 1x, and then I've got that negative 3 all by itself. And from there, I'm done. I can't simplify anything else. I've combined like terms, and I'm good to go. Go ahead and see if you can find the answer for this one, and then press play when you're ready to check. So this should be option 3, 5 plus 2 is 7a, and then negative 3b plus 6b is positive 3b. So if you haven't noticed, everything we just did was addition examples, so we're going to take a look at subtraction right now. And I have this, nice and big to point this out because this is an area where people will make mistakes if you ever mess anything up for this kind of stuff. So when you're subtracting a polynomial, make sure you subtract the entire polynomial that you're actually subtracting, which means you're going to distribute your negative to everything. You cannot just subtract one of the terms in a polynomial. If you're subtracting something that has 3 different parts, you have to subtract all of it. So let's take a look at a couple of examples of that. Alright, so our first example here, we've got this entire trinomial, 6w squared minus 5wz minus 3z squared, and then you're subtracting that whole entire second trinomial, 4w squared plus 6wz minus 8z squared. So what you need to think about is that it's minus 4w squared minus 6wz minus negative 8z squared. So you have to distribute that negative, and then I always suggest to rewrite everything and change those signs right now so you don't make mistakes. Because when people try and just combine like terms without rewriting, that's where the mistakes happen. So what I've done is I've just rewritten each of these parts. That becomes a minus, that becomes a minus. This actually becomes a plus because you were subtracting a negative. Once you do that, it's just one step away. You're looking for any like terms, and you're going to go ahead and just combine them the same way we did with addition. So you're going to go ahead and look for any like terms, and you can color code. You can actually just underline or circle them, something like that I do, but I've just color coded right here. And then I'm going to put together what I have in different colors. So 6 minus 4w makes 2w squared, negative 5wz minus 6wz is negative 11wz, and then negative 3z squared plus 8z squared is 5z squared. And that is all you can do for that one, so at that point you would be done. So example 2 is the same kind of thing. I've got this first trinomial, and I'm subtracting both parts of this second binomial. So I'm going to go ahead and rewrite first. So I've gone ahead and done my rewrite, and now I'm looking for any like terms. So I've got 7p squared minus p squared over here, which makes 6p squared. I've got this negative 1p and no other p's, so that's just going to stay a negative 1p. And then I have negative 7 minus 11, which should be negative 18. And then at that point you're done, since nothing else here can be simplified. Right, third example, same thing. So you're subtracting this entire trinomial over here to the right, which means you're going to want to stop and rewrite and distribute that negative, and then you can combine like terms. So when you distribute, this is what you should end up getting: a plus 3x squared, a minus 6x, and a plus 1. And now you're looking for like terms. So 2x squared plus 3x squared means you have 5x squared. You've got negative 5x minus 6x, which makes negative 11x. And then we've got 7 plus 1, which gives you 8. And then from there you're done. Go ahead and try number 4 on your own, and then press play whenever you're ready to check it. So final answer here should have been option 1. And again, you distribute that negative, you combine your two a's, you combine your two b's, and that should give you 3a minus 9b for a final answer. So these last 4, again, very popular kind of questions where they're going to have you use concepts that you've learned, but in context of something like a shape. So for these four, we're going to find the perimeter of each shape, and if you forgot, perimeter is just when you add all of the outsides to a shape, all the values, so we're really just looking to combine like terms for everything along the outside of these shapes. So I'll do the easy triangle one with you guys right now, and then you could try the other three, and then we'll check those. The triangle already gives you all three sides, so we're realistically just saying 4x plus 4x plus 9. And if you're going to simplify that perimeter, the two 4x's become an 8x plus 9. And that would be your perimeter, and you are basically done with that one. I do want to just warn you when you're doing the other ones, if you're going to go ahead and do it, example 1, this is only showing you 2 of the 4 sides of this rectangle. So you would have to realize that if the bottom is x plus 6, then the top is also x plus 6. And if the right side's 3x minus 5, then your left side is also 3x minus 5. Now when you go to do your perimeter, you can just add everything up that you see that's like terms and represent your perimeter that way. So you can press pause and try the 3 rectangles that are here, and then press play when you're ready to check what you got for each perimeter. Alright, so that first rectangle should have had a perimeter of 8x plus 2, and that's just combining your x's and combining your constants. Your third one should have a perimeter of 6x squared plus 2x plus 2, and again that's combining the x squareds, the x's, and the constants separately. And then the last one should end up being 4x squared minus 2x minus 12 when you combine each of your like terms. So that really shouldn't be that hard if you ever see a shape and it says find perimeter. It literally is just asking you to add everything on the outside or combine like terms. And that is everything for this section, so hopefully it was pretty easy for you guys. I'll see you later.